Morning. Okay. So in the last classes, we discussed about the Fourier transform and its related problems. So Fourier transform, by using the Fourier transform formula, we can find out the Fourier transform and draw the uh, frequency spectrum or magnitude spectrum and phase spectrum. Okay. So up to here, up to this problem, we solved in the last classes. Okay, now we will see one or two problems and then we will start the properties of Fourier transform, right? So next problem is find the continuous spectrum of non-periodic signal x of t as shown as it is from x of t is given like this: from minus tau to 0 its value is a, from 0 to tau its value is minus a. So x of t is defined as x of t equal to a for minus tau is less than or equal to t is less than or equal to 0, and it is equal to minus a for 0 is less than or equal to t is less than or equal to tau, or else it is 0, right? We have to find out the Fourier transform for this problem. So how to find out the Fourier transform? What is the formula for finding the Fourier transform? X of omega is equal to Fourier transform of x of t, that is integral minus infinity to infinity, right? X of t into e power minus j omega t dt, right? So here x of t has two functions. So from minus tau to 0, its value is a into e power minus j omega t dt, plus from 0 to tau, its value is minus a. Okay, minus a into e power minus j omega t dt, right? So a is some constant. So integral 1 in integral e power minus j omega t. So e power minus j omega t by minus j omega with limits 0 minus tau, plus a is some constant. So e power minus j omega t by minus j omega, that is minus into minus gets plus. So with the limits tau and 0. So by simply solving this, we can get a value is this x of omega value is a into minus 2 by j omega plus e power j omega tau plus e power minus j omega tau by j omega, right? So taking 2 as outside, so 2a by j omega taking as common, so it is minus 1 plus e power j omega tau plus e power minus j omega tau by 2. This is nothing but cos omega tau, right? So j into 2a by j into j becomes j square, so that it will become, so j square is minus 1, so minus 1 gets common, so j into 2a by omega into minus 1 plus minus 1 1 plus 1 minus e power j omega tau plus e power minus j omega tau by 2. This is nothing but cos omega tau. 1 minus cos omega tau. Or we can write 1 minus cos 2x is, it is in the form of 1 minus cos 2x is 2 sin square x. So it is equal to 2 sin square omega tau by 2. Okay. Or we can write this as j omega tau square sin square SINC sin square omega tau by 2 pi, where sin function of x is equal to sin pi into x by pi x. So it is in the form of sin pi into x by pi x, so that we can write this as sin square omega tau by 2 pi. So the Fourier transform of the given problem is j omega tau square into sin square omega tau by 2 pi, right? So that is the problem. Next problem is find the Fourier transform of signum function shown below. Signum, how the signum function is defined? So it is defined like this. So signum of t is minus 1 from minus infinity to 0, or t is less than 0. It is 0 at t equal to 0, and it is 1 for from 0 to infinity, or t is greater than 0, right? So it is minus 1 for t is less than 0, it is 0 for t equal to 0, and it is and it is and it is 1 for t is greater than 0, right? Okay, so it is defined like this. So signum of t equal to minus 1 for t is less than 0, it is 0 for t equal to 0, and it is 1 for t is greater than 0. Or in other way, it can define as signum of t equal to u of t minus u of minus t, u of t minus u of minus t, right? So graphical representation of the signum function is like this: signum of t It is t equal to 0, it is minus 1. T is greater than 0, it is 1. And at t equal to 0, it is 0. Okay. So x of omega, that is Fourier transform of the signum of function x of t, or signum of t is equal to integral minus infinity infinite signum of t into e power minus j omega t dt. So it is minus infinity to 0 signum of t into e power minus j omega t dt plus integral 0 to infinity signum of t into e power plus j omega t dt, right? Okay. So minus infinity to minus infinity 0 signum of t into e power minus j omega t dt plus integral 0 to infinity signum of t into e power j omega t dt. So from minus infinity to 0, what is its value? Minus 1. From 0 to infinity, what is its value? 1. Okay. So it is minus infinity 0 minus 1 into e power minus j omega t dt plus integral 0 to infinity 1 into e power minus j omega t dt, right? So it is a minus of integral minus infinity 0 e power minus j omega t dt plus integral 0 to infinity e power minus j omega t dt, right? So by simply solving, we can get 1 by j omega plus 1 by j omega. It is 2 by j omega, or Fourier transform signum of t equal to 2 by j omega. So what it is magnitude of 2 by square root of omega square, that is 2 by omega. Okay. And phase angle is only imaginary term is the real term is 0. So minus tan inverse omega by 0, that is tan inverse infinity, it is equal to plus or minus pi by 2. So for 2 by omega, the magnitude plot is this one, and for plus or minus pi by 2, the phase plot is this one. Okay, this is about the Fourier transform of the signum of t. So next, find the Fourier transform and sketch magnitude spectrum of unit impulse function. Unit impulse function, right? Unit impulse function. So what is the definition of impulse function? Impulse function exists only at t equal to 0. So delta of t equal to 1 at t equal to 0. Okay. So it is unit impulse function, diagrammatical representation. So delta of t equal to 1 for t equal to 0, it is 0 otherwise. Okay. So delta omega equal to integral minus infinity to infinity delta of t e power minus j omega t. But it exists only at t equal to 0. So integral 0 to infinity 1 into e power minus j omega, p value is 0. E power j omega into 0, that is e power 0, that is 1. So its value is 1. Okay. So magnitude spectrum is as follows. It's from minus infinity to infinity. Its value is unity. Okay. And next problem is find the Fourier transform and sketch the spectrum for unit step function. Unit step function. So unit step function diagrammatical representation is this one. Okay. So what is it's mathematically defined u of t equal to 1, u of t equal to 1 for t is greater than 0, and it is 0 for t is less than 0. The function u of t can be considered as sum of the two functions, signum function and constant function. By adding these two functions also, we can get the unit step function. So this is signum function, and this is a constant function, some constant function having the amplitude 1 by 2. Okay, so it is the half signum function. So from minus infinity to 0, its value is minus half. From 0 to infinity, its value is plus half. Okay. So by adding half signum function with some constant function having the amplitude 1 by 2, so that we will get the unit step function. Okay. So it is u of t equal to half of signum of t plus 1 by 2. Okay. So we can we add these two functions. By adding these two functions, we can get the unit step function, half of the signum function and the constant function having the amplitude 1 by 2, so that we will get the unit step function, right? So that is mathematically expressed as u of t equal to half of signum of t plus half. It is a constant function having the amplitude half. So it is equal to Fourier transform of half of signum function plus half. So already Fourier transform signal function is 2 by j omega, and Fourier transform of the constant is 2 pi into delta of omega. Okay, so by adding these two, we can get Fourier transform unit step function is 1 by j omega plus pi of delta of omega. So the magnetic spectrum for this one is this one. Okay, so this is the magnetic spectrum of the unit step function. Now coming to the properties of the Fourier transform. So here we have the 9 important properties of Fourier transform. There, those are linearity property, time shifting property, frequency shifting property, differentiation property, integration, scaling property, duality property, convolution property, and Parseval's theorem. So first one is linearity property. How it is defined? If the Fourier transform of x of t is x of omega, and Fourier transform of y of t is y of omega, then a into some constant a into x of t plus b into y of t, the Fourier transform of this entire expression will become a into x of omega plus b into y of omega, where a and b are constants. Okay. Next, second one is time shifting property. So how it is defined? So the Fourier transform of x of t is x of omega. Then Fourier transform of x of t minus t naught. Here the time will be shifted from t to t naught units. Okay. So Fourier transform of x of t minus t naught is nothing but e power minus j omega t naught into x of omega, right? So we'll take the Fourier transform of x of t minus t naught. So integral minus infinity infinity x of t minus t naught into e power minus j omega t dt. Let t minus t naught be k, or t will become t naught plus k, or dt will become dk, right? So Fourier transform of x of t minus t naught is equal to integral minus infinity infinity t minus t naught will be replaced by k, so that it is x of k into e power minus j omega. T is replaced by t naught plus k. Okay, and this t is replaced by t naught plus k, right? So it is minus infinity infinity x of k into e power minus j omega t naught into e power minus j omega k into dk. Dt is dk, right? So e power j omega t naught can be extracted outside. So integral minus infinity infinity x of k into e power minus j omega t dk. This is nothing but x of omega. So that the Fourier transform of x of t minus t naught will become e power minus j omega t naught into x of omega. Hence proved. Next property is frequency shifting. So if the Fourier transform of x of t is x of omega, then the Fourier transform of x of t into e power j omega t naught will become x of omega minus omega naught. Here the frequency will be shifted from omega to omega naught. In the earlier one, the time will be shifted from t units to t naught units, right? Right? Okay. Let it be proved. How to prove it? So the Fourier transform of x of t into e power j omega t naught is equal to integral minus infinity infinity x of t into e power j omega t naught into e power minus j omega t dt, right? J omega is common, so integral, this is j omega naught t naught. So j omega x of e integral minus infinity infinity x of t into e power minus j into omega minus omega naught into dt, right? Omega minus omega naught into dt, or it is nothing but x of omega minus omega naught. Next, coming to the scaling property. Scaling property. How it is defined? The Fourier transform of x of t is x of omega. Then the Fourier transform of x of a t is 1 by a into x of omega by a. 1 by a into x of omega by a, right? So x of a t. So integral minus infinity infinity x of a t into x of a t into e power minus j omega t dt. Let a t be t, or t equal to t by a, for a is greater than 0, right? So integral minus infinity infinity minus infinity plus infinity a t is replaced by p, that is x of t into e power minus j omega into t is replaced by p by a into t of p by a, right? It is equal to 1 by a into, okay, x of integral minus infinity infinity x of p into e power minus j omega p by a into tp, or it is 1 by a into x of omega by a, right? So similarly for a is less than 0, it is a Fourier transform of x of a t is 1 by minus a into omega by a, or in general we can write the Fourier transform of x of at as 1 by mod a into omega by a. Next property is convolution property. As we already know that the convolution in time domain will become simple multiplication in frequency domain. The convolution in time domain will become simple multiplication in frequency domain. Let us consider the linear time invariant system, that is h of t, having the impulse response h of t, its input is x of t and its output is y of t. So the Fourier transform of this x of t is x of omega, and Fourier transform of y of t is y of omega, and Fourier transform of this impulse response h of t is h of omega. Then this output or response y of t is defined as x of t convoluted with h of t, x of t convoluted with h of t. So what is the definition of convolution? That is minus infinity infinity x of tau into h of t minus tau d tau, right? So then Fourier transform of x of t convoluted with h of t will become Fourier transform of x of t multiplied by Fourier transform of h of t. What is Fourier transform of x of t? That is x of omega. What is Fourier transform of h of t? That is h of omega. So x of omega multiplied by h of omega. And Fourier transform of x of t converted with h of t is nothing but y of t. Fourier transform of y of t. So Fourier transform of y of t is nothing but y of omega. So finally, y of omega will become x of omega multiplied by h of omega. We have to prove this. Okay. So from the definition of the convolution, y of t is equal to integral minus infinity infinity x of tau into h of t minus tau d tau, right? H of t minus tau d tau. Taking Fourier transform on both sides, we get y of omega is equal to integral minus infinity to infinity, this whole expression, that is y of t, integral minus infinity infinity x of tau into h of t minus tau d tau is nothing but y of t into e power minus j omega t dt, right? Now changing the order of integration, that is integral minus infinity infinity x of tau into integral minus infinity infinity h of t minus tau d tau into dt whole into d tau, right? So h of t minus tau into e power minus j omega t dt is nothing but Fourier transform of h of t minus tau, right? If you take the Fourier transform of h of t is h of omega, then Fourier transform of h of t minus tau, it is nothing but a time shifting property, that is e power minus j omega tau into h of omega, right? So y of omega will become integral minus infinity infinity x of tau is already there. This Fourier transform of h of t minus tau d tau is nothing but e power minus j omega tau into h of omega and this d tau, right? So x of omega, h of omega can be extracted outside into minus infinity infinity x of tau into e power minus j omega to d tau, or this integral minus infinity to infinity x of tau into e power minus j omega to d tau is nothing but x of omega. So this is h of omega into x of omega, or it is x of omega multiplied by h of omega. This is y of omega. This is the convolution property. Next one is time differentiation property. Time differentiation. Time differentiation is differentiation. We are differentiating the x of the function. So how it is defined? If the Fourier transform of x of t is x of omega, then the Fourier transform of d by dt of x of t is nothing but j omega into x of omega. Similarly, next property is time integration property. If the Fourier transform of x of t is x of omega, then Fourier transform of integral minus infinity into x of t dt will become x of omega by j omega plus pi of pi into x of 0 into delta of omega. Here, pi into x of 0 into delta of omega indicates that dt term are average value. This is the dc term are average value. So this is the time integration property. And next one is Parseval's theorem. Parseval's theorem. So how it is defined? The total energy of the signal x of t can be determined either by integrating power in time domain over all time, or integrating power in frequency domain over entire range of frequencies. We can determine either by time domain as well as frequency domain. How to determine it by time domain? So by integrating power in time domain over all time, or integrating power in frequency domain over entire range of frequencies. So mathematically it is defined like this. The Fourier transform of x of t is x of omega. Then Parseval theorem states that integral minus infinity into mod x of t whole square dt is equal to 1 by 2 pi integral minus infinity into infinity mod x of omega square d omega. So that is nothing but integrating power in time domain over all time, or integrating power in frequency domain over entire range of frequencies. Next property is duality property or symmetry property. Duality property or symmetry property. If the Fourier transform of x of t is x of omega, then the Fourier transform of x of t will become 2 pi into x of minus omega. This is capital X of t and this is small x of t. Remember. Okay, so the Fourier transform of small x of t is capital X of omega. Then the Fourier transform of capital X of t will become 2 pi into small x of minus omega. So the general expression for the inverse Fourier transform is inverse Fourier transform of x of omega is nothing but x of t is equal to 1 by 2 pi into integral minus infinity to infinity x of omega into e power j omega t d omega, right? So similarly, x of minus t is 1 by 2 pi into integral minus infinity to infinity x of omega into e power minus j omega t d omega, right? Or by cross multiplying this one, so 2 pi into x of minus t is equal to integral minus infinity to infinity x of omega into e power minus j omega t d omega. Since omega is dummy variable, interchanging the variables t and omega, okay, t and omega. So we will get the 2 pi into x of minus omega, means that t is replaced by omega. So integral minus infinity infinity, this omega is replaced by t. So x of t into e power minus j omega t dt. So this is nothing but our Fourier transform of x of t. So Fourier transform of x of t is equal to 2 pi into x of minus omega, hence proved. Our Fourier transform of x of t is 2 pi into x of minus omega. So for an even function, x of minus omega will become x of omega, so that x of t, Fourier transform of x of t is 2 pi into x of omega. This is the duality or symmetry property. Okay, so these are the important properties of the Fourier transform. So with this, I am concluding the today's class. In the next class, we will discuss about the Parseval's theorem for energy signals, Fourier transform of periodic function. Okay, and we will do some problems, right? Okay, with this, I am concluding the today's class. Thank you.